Hello dear students, today we are discussing a new topic, and that is combination of resistances. In our previous class we already have discussed resistance, resistivity, Ohm's law and other related material matters of this relation. So today we are directly coming to discuss this combination of resistances. Now, what is combination of resistances? In some special electric circuits, what is done? Different resistors are joined with each other to get an equivalent resistance or a desired resistance. Such a combination of more resistors, maybe 2, 3, 4, 5 resistors together, is called as a combination of resistors. This combination of resistors can be of two types. That means to say that when many resistors are combined together, then there may be two different types of arrangements, and these two different type of arrangements are called as number one, series combination of resistors, and number two, parallel combination of resistors. So let us discuss those series and parallel combination of resistors. So let us see, this is the series combination of resistance, and here this is parallel combination of resistances. Now what is series combination? Series combination is that when the resistors are connected serially one after another. How? That is, the negative terminal of the first resistor should be connected to the positive terminal of the second, and similarly the negative terminal of the second will be connected to the positive terminal of the third. So in that way, when the resistors are connected serially one after another, we get a series combination of resistors. That is, so when two or more resistors are joined end to end so that the same current flows through each of them, then this combination of resistors is called as series combination. But now what is parallel combination of resistors? Parallel combination of resistance is that where all the positive terminals of the resistors will be connected to one particular terminal, and all the negative terminals of the resistors will be also joined at the common point. So when two or more resistors are connected between two common points so that same potential difference is applied across each of them, then that combination of resistance is called as parallel combination. Now let us understand this series combination and parallel combination with the help of diagrams. Imagine we are having three resistors, R1, R2 and R3. Three resistors we are having. Now this is R1, first resistor, this is the second resistor R2, and this is the third resistor R3. In this diagram also we are having these resistors 1, 2, 3, and these resistors are R1, R2 and R3. So these are the three resistors we are taking into consideration in both the diagrams. Now what is done? Here we can see these resistors R1, R2 and R3 are connected in this circuit, and they are connected one after another. That is how? That is, after R1 we are placing R2 in such a way that the negative terminal of the first resistor is connected to the positive of the second, and negative of the second is connected to the positive of the third. So that is the series combination. And here what is done? R1, R2 and R3 we are placing these resistors parallelly. Then these are all positive terminals, and all the positive terminals are connected at this common point, and these are the negative terminals, and they are also connected at this common point. Now in this way, when the resistors are connected, and then we call this combination of resistor as parallel combination of resistors. Now let us come back to this series combination of resistance. According to the statement here, what we have mentioned, that is, when two or more resistors are joined end to end so that the same current flows through the arrangement, then this is series combination. That means in series combination current will remain constant. So according to this statement, I is constant, means the current is constant. Thus the potential difference through the three resistors will be different. If the current remains constant, the potential difference will be different. Now imagine this three resistors when they are connected in series in this circuit. This is the source of current, that is potential difference is applied V. This is the plug key K. When the plug key is on, that means the circuit is on, then the current will flow in this direction through R1, then it will pass to R2, and then it will go to R3. In all the three conditions, that is through all the three resistors, current passing will be constant. But what will happen to the potential difference of the battery? Suppose this battery has potential difference 12 volt, then the first one will get 4 volt current, second one also will get 4 volt, and the third one also will get 4 volt. So all the three resistors, 4 volt plus 4 volt plus 4 volt, will be total 12 volt of this battery. So to say that what will be the volt of this resistance, we can diagram it, still mathematically represent it. V1, that is the potential through the resistor 1, V1 will be equal to IR1. We are getting this formula from Ohm's law. V is equal to IR. That is, potential difference is equal to current into the resistance. So if V is equal to IR, then V1 will be equal to IR1. Here I is constant. Similarly, what will be the potential difference across the second resistor V2, and V2 is equal to IR2. And accordingly, what will be the potential difference across the third resistor R3? It will be V3, that is equal to IR3. In all these conditions, as I have already mentioned, that is V is equal to therefore V1 plus V2 plus V3. That is V is equal to V1 plus V2 plus V3. Now if we apply this formula, V is equal to V1 plus V2 plus V3, then in place of V we can write IR. Similarly, in place of V1 IR1, so we will place the value here IR1. Similarly, V2 is equal to IR2, V3 is equal to IR3. So we are getting, that is V is equal to V1 plus V2 plus V3. That means in the second line we have got, that is IR is equal to IR1 plus IR2 plus IR3. Now we can take I common on both the sides, and finally by cancelling I from both the sides, we will get R is equal to R1 plus R2 plus R3. Means this R is called as equivalent resistance in series combination, which is always equal to the sum of the three resistors. That is, total resistance in the circuit, that is R, will be is equal to R1 plus R2 plus R3. So this is how we will get the combination of resistance in case of parallel combination. Now we will discuss one thing. If in this circuit the value of the first resistor, that is R1, is equal to 1 ohms, we have written it. If R1 is equal to 1 ohm, means this resistor has value 1 ohm, this resistance has value 2 ohms, and this resistance has value 3 ohms. That is R1 1 ohms, R2 2 ohms, and R3 equal to 3 ohms. Then what will be the total resistance in the circuit? It's very simple. That is R is equal to R1 plus R2 plus R3. That is equal to 1 plus 2 plus 3. That is equal to total resistance in this circuit will be 6 ohms. This is to say that how to calculate the total resistance in a series combination. The total resistance or equivalent resistance in series combination is the sum of the individual resistors connected in the circuit. That is R is equal to R1 plus R2 plus R3. So now we will see what are the disadvantages of this series combination. So series combination is the first disadvantage. If one component or if any one appliances in this circuit is fused or damaged, then the whole circuit will stop functioning. That is to say that if current is flowing through this wire due to application of this potential difference, and current is passing through this R1, then going to R2. Suppose R2 is damaged, then the circuit will stop functioning. The circuit will never work. So this is the first disadvantage of series combination, is that if any one of the appliances in the circuit is damaged or it is fused, then the entire system will stop functioning. The second disadvantage is that since equivalent resistance in this series combination is maximum, therefore current flowing through the circuit will be the minimum. So this is the second disadvantage. So after going through this series combination, now we are coming to the parallel combination. As we have already discussed that in parallel combination we will always have one thing constant, and what is that? That same potential difference will be applied. That means V will remain constant. So current will change. Now, if this is a circuit where we are applying potential difference V, this is the plug key, current is passing through the circuit, then what will happen? At this point, the current will change because you have three different destinations. One route is through this R1 resistance, second is through R2 resistance, and the third route is through R3 resistance. Means the current flowing through the wire has to bifurcate. It has to divide into three different routes. That is to say that if the total current in the circuit at that point was I, if we say this is the current in the circuit, total current was I, then through this current passing will be I1, through this route I2, and through this route it will be I3. Means you can see that current is not constant, current is changing. That is to say, according to the statement here in this diagram, V is constant, potential difference is constant. So the current passing through the three resistors will definitely be different, and they will be, what will be the I1, I is equal to V by R. This is again Ohm's law, I is equal to V by R. So I1 is equal to V by R1. Why? Because V is constant, V will never change. So I1 is equal to V by R1. Similarly, I2 will be equal to V by R2, and I3 will be equal to V by R3. So in that way we are getting, these are the three currents passing through the three different resistors, R1, R2 and R3. So according to this statement, as we have come to know that I is equal to I1 plus I2 plus I3, in place of I we can write V by R. Similarly, in place of I1 we can write V by R1, in place of I2 V by R2, and in place of I3 V by R3. So we are getting V by R is equal to V by R1 plus V by R2 plus V by R3. Now if we take V common on either side, then we will get V by R is equal to V into 1 by R plus 1 by R2 plus 1 by R3. Cancelling V from either side, we will get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is how the equivalent resistance in parallel combination can be calculated. Now let us see the same example. This R1, R2 and R3 has values again 1 ohms, 2 ohms and 3 ohms, like in case of series combination we have taken. Now if the value of R1, first resistor is 1 ohm, that means this value of the resistor is 1 ohm, value of the second resistor is 2 ohms, and value of this third resistor is 3 ohms. Then what will be the equivalent resistance in this circuit? As we have got the formula, so we are placing the formula 1 by R is equal to 1 by R1, means what is the value of R1? 1, so 1 by 1. The 1 by R2, that is 1 by R2, what is the value of R2? That is 2 ohms, so 1 by 2, and accordingly 1 by 3, because R3 has value 3 ohms. So we are getting 1 by R is equal to 1 by 1 plus 1 by 2 plus 1 by 3. Now if we do the simplification, we will get 1 by R is equal to 11 by 6. 1 by R is equal to 11 by 6. Since 1 by R is equal to 11 by 6, therefore R will be equal to 6 by 11. That will be equal to equivalent resistance 0.54 ohms. Means the total equivalent resistance in this combination is very small. Resistance is very small. It is less than 1 ohms. And what was the smallest resistor? 1 ohm. And that is to say that the equivalent resistance in parallel combination is always smaller than the smallest resistor used in the circuit. Now what are the advantages of this parallel combination? Parallel combination has the first advantage: if one component in this circuit is damaged or fused, we have to take no tension. Why? Because the rest of the component in the circuit will still continue functioning. That is the first advantage. And the second advantage, since the equivalent resistance is very less in this combination, therefore current flowing in the circuit will be maximum. So this was to discuss about the combination of resistors, series combination and parallel combination. Thank you.